In this episode of Hot Hardware's 2.5 Geeks, we have been infiltrated by NVIDIA. They have hijacked our stream. It's like that Rage Against the Machine song, lights out, guerrilla radio. Yeah, so turn it up. Next. Welcome back to another episode of Hot Hardware's 2.5 Geeks. I'm Dave Altavilla, and with me, as always, is the incomparable and illustrious Marco Chiappetta, managing editor of HotHardware.com. Marco, how are you? Quickly.
I'm fantastic. I'm very excited to have our special guest on here. Lots of exciting stuff going to get talked about soon. So
I was gonna say I didn't mean to rush you. I didn't mean to give you the bum's rush, but we got an important guy here. We got Tom Petersen from NVIDIA with us this evening, and Tom is the director of technical marketing for NVIDIA, and a general nice guy to boot. Tom, how you doing?
I'm doing great, Dave. How you guys doing?
We are we're surviving up here in the Northeast. We've got a heat wave right now. It's about 95 degrees and stinking humid.
Wow, that's
right, Marco.
Yeah, it's as soon as you go outside, your clothes stick to you today. It's been brutal.
It's not like the perfection you have in California.
I'm empathetic for you guys, but you know what? Today it was gorgeous here in beautiful California. Just gorgeous. I was even in the hot tub this morning early. So
you were in the hot tub. California dreams. Tom, whereabouts are you?
I'm in beautiful San Jose. So literally right in the center of Silicon Valley. Here all the time.
Excellent. So before let's dive in, but before we do, give us a little bit of background on you, and for the viewers, just what you're all about at NVIDIA, what you do, director of technical marketing. So we know you're a smart guy, but what is a technical?
Well, actually, I
think
my actual title is probably a distinguished engineer at NVIDIA. So that means that I guess, and so what I kind of do is half of my life is spent trying to think of technology and how can we take the latest technologies and apply it to gaming and make gaming better, just through science and applying the latest thinking and the latest thinkers and making it better. The other half of the time I spent, enjoying gaming. I play games all the time. I get to get the latest games all the time. And then I also talk to press a lot to try to help, bridge that gap between hardcore technology and hardcore gaming stuff and help it make it more accessible to all the rest of us who, if you're not an engineer and you don't have a master's in electrical engineering, sometimes what we say could be confusing. So I like to try to take complex topics and then convert it to human understandable dialogue.
Make things digestible, as they say, right?
Yeah, because having great technology is important because you get a great experience, right? If you get the latest NVIDIA tech, you're going to have a great gaming experience. And that's the primary way people kind of get to enjoy us. But there's another whole group of people that like to know, what's going on inside of this GPU and what is that tech? And they just enjoy understanding, the elegance of what's inside.
And you've got, I think last time we spoke, it occurred that you have a couple of patents to your name. That you were involved in the development or invention of G-Sync and a few other things, maybe?
Yeah, well, I'm constantly inventing things, or at least trying to invent things. I had a hand in G-Sync with a bunch of other really smart people, and things like GPU boost and my career goes back 20 years now. So I haven't counted recently, but somewhere around 50 patents.
Wow. 50, 5-0.
5-0 roughly. Don't quote me. It's more than 40, less than 60. You need
the wall behind you, dude, like in your office there, behind you, the wall of patents.
You know what I'm most proud of right now? Here, let me show you this. This is exciting.
Go for it. Chair surfing.
This is what I'm currently most excited about. Other than my real game, my real work, which is gaming, I'm really super into AI right now. So I actually just got done doing this, which is applying AI to opioid prediction and trying to figure out who is going to become addicted to opioids. I did this while I'm taking some classes at Stanford, trying to get to be relatively competent in how we can use AI in gaming. So it's really an exciting time to be at NVIDIA. I mean, we're right at the center between AI and graphics, and I couldn't be in a better job.
Yeah, that's awesome. By the way, it's great to to design and invent solutions that entertain us, but also saving lives is a pretty wonderful thing too. My goodness, boy, and you're right. You're absolutely right. We are at what feels like an inflection point in technology, to the point where we're getting such power and capability with these new solutions that are being developed by companies like NVIDIA, that some pretty amazing things are beginning to take shape. And so, yeah, it's exciting. It's fun to do what we do.
Oh,
we report on you, but you keep doing what you do. We just report.
I got to tell you, there's so much new on Turing that I think people are just going to be digesting it for months, because it's a brand new way to think about generating images. We have three major chunks of new technology that are in it. Of course, Turing is just our next generation GPU. So all of the games that you've got today are just going to all run faster, because we've made our shader better, we've made our core better, our memory is better. So our perf onto this, existing games just goes through the roof. It's in general a beast, which is pretty much awesome and most important for everybody. But the other two tech that I get super excited about are, we've added AI into the chip. So the chip actually has what we call tensor cores, which are hardware designed to accelerate AI processing. So things like inferencing can now be done while you're playing games, and we can build that AI into how the games perform. And I'll talk more about that in a little bit. And the third tech that we've added is real-time ray tracing. So now, instead of doing everything with rasterization, which is a great technique, and it allows us to get real-time images, very high quality, now adding on top of that ray tracing and doing hybrid rendering modes allows us to make lighting look perfect. So things like shadows and reflections and ambient occlusion, and even someday global illumination, all of those key graphics technologies look dramatically better with ray tracing. So it's three new ways of computing that are all going to improve the frames that are rendered for games. And so we're changing a lot of things about how we think about it, and it's a huge investment that's going to take a while and lots of innovation as we go forward.
Yeah. On August 20th, Monday, August 20th, NVIDIA unveiled GeForce RTX 2080 Ti, RTX 2080, and RTX 2070, shipping September 20th, starting at $499, and powered by that new Turing GPU that you mentioned. John, you can, by the way, hit links as we talk through them on the site, just to show folks. There you go. There's the trio of cards right there. And so I don't want to steer the conversation too much one way or the other. I will say that we absolutely want to hear from the gallery here, and try and get as many questions, answers from the viewers as we can. We do have to respect a certain amount of NDA, sort of embargoed information that has not been disclosed yet, that will be at launch, or I'd say when the card will ship. But Marco, I know I went to Germany, and I went and soaked it up over there in Cologne. It was beautiful in that beautiful city with the folks at NVIDIA when they launched at Gamescom. But Marco, I know you've got some questions. Why don't we hand the first round over to you and get us rolling here, and we can pepper Tom with some Q&A.
Yeah, definitely. So I want to tell everybody in the chat, Dan, I see your questions in the chat. We'll definitely get to those a little later. I have a couple of just foundational questions I'd love Tom to answer, just to kind of set everybody in the right tone for what Turing is all about. One of the things that struck me in Jensen's talk from Gamescom was how, it's sort of a new performance paradigm. And he was talking about tips and talking about giga-rays and having fun with all the new terms that he's throwing out there. So I believe that I'm fairly clear on what the terms mean, on what Jensen was talking about. Well, why don't you tell everybody what a giga-ray is? Like, my understanding is that the highest end, the 2080 Ti, I believe it was 10 giga-rays that Jensen loved throwing out there. Does that mean that in one particular second, a 2080 Ti could be, have 10 billion ray traced rays in flight? Is that what that number means?
At a very high level, Marco, you're absolutely right. That number is meant to be a performance-y kind of number, and a gigaray is obviously a billion rays casted per second. And you can think of it as a 1080 Ti today has to emulate all of those, all the processing that has to happen to do array, to do casting, all of that. It has to do all of that without having actual hardware to accelerate that process. And a 1080 Ti today can do about 1.1 gigaarrays, right? Now, if you compare that to a 2080 Ti with the hardware inside, that 2080 Ti can cast about 10 billion gigaarrays. I'm sorry, 10 gigaarrays. So it's about a 10x perf improvement from going from 1080 Ti to 2080 Ti in terms of the amount of rays that can be cast per second. Now, our 2080 Ti number comes from real testing. It's not a calculated synthetic benchmark. It's actually across a series of sort of typical ray traced kind of workloads, calculating a mean average perf for those workloads. So it's not a sort of a mathy thing. It's like, how many rays can I cast? And using the new hardware, we can cast around 10 gigaarrays.
Yeah, that was a question that was posted up on Reddit, so it was good to get an answer on that. Thanks for quantifying that, Tom.
Yeah.
So let me also ask. Now, we know that to fully leverage Turing and the GeForce RTX technology, a game has to be coded to support those cores and the new tech that's in this GPU. But DirectX also has some ray tracing built in. Any DirectX 12 GPU can technically run some ray tracing workloads. But are people, there was a whole list of games that are going to support the RTX technology, which is either ray tracing or DLSS or both. But are games that support RTX tech, are people going to be able to turn on those ray tracing modes on other GPUs? They'll just perform poorly, or they will not even be able to see what it looks like?
I think that's up to the game developer, but I would expect most of these game developers that are coding ray traced enhancements for their game will usually, assuming that they're DX, they'll use the Microsoft Open API DXR. And that is not a NVIDIA, it's not an NVIDIA proprietary way of coding up ray tracing. It's a generic, it's an open way of describing the behavior that you'd like to accomplish on ray tracing. Now, on an NVIDIA GPU, especially a Turing GPU, that's going to run really well, right? Because we worked with Microsoft on DXR, we've implemented RTX, and RTX is all about making those operations run really, really fast. But those same operations can be emulated on older hardware. I gave you a Pascal number that's roughly, a 10x improvement between Turing and Pascal. So you can still expect it to run using DXR in an emulated mode, but it would not run very fast.
Gotcha. Now, the RT cores, the ray tracing cores, this is actually a question that just popped in, and it's kind of a good segue. Those RT cores and the tensor cores in Turing, are they just going to be used for RTX technology, or are they going to be exposed in CUDA as well? Like, is there going to be some new programming models for people that want to take advantage of those cores?
Sure. Tony's done a good job describing, and I know this will come out more in the press over the next couple of weeks, but our hardware is generally exposed in two ways. The new hardware, tensor cores, are exposed through CUDA, and you can access those in the same way that you do in other tensor core enabled GPUs. So that's not new, and that will of course be enabled through CUDA. RTX cores are enabled through optics. So optics is sort of our low-level API for doing ray tracing. And if you really want to do a low-level application using the ray tracing hardware, you can certainly do that. Again, it's much more common that developers will use a higher-level API through either RTX or through DXR. But if you're a real hardcore, computer scientist, you want to get into CUDA, you want to get into optics, those are also available.
Very
Gotcha. Cool. And actually, while we're on the subject of tensor cores, I had a question that I wanted to understand a little bit more, because folks are sort of, it's new. And so, there's immediate doubt with something that's new. What's this all about? Can it be that good? DLSS and how that runs on the tensor cores, what it's actually doing. There's inferencing going on. It's AI. walk us through that a little bit if you could, because what I saw and what we demoed, on video at the event in Cologne was what looked to me like a really nice AA image, a standard TAA, temporal anti-aliasing, running at like mid 30s frames per second, looking sharp, and it was the Infiltrator demo, Unreal Engine Infiltrator demo. And then on the other side was DLSS enabled, TAA off, so no anti-aliasing enabled in the traditional sense. And it was running the Infiltrator demo, same resolution at 2x the frame rate, 80 frames per second, or more, 60 to 80 frames per second, I guess was the range. To my eye, and certainly in motion, things looked darn near identical. I mean, I couldn't tell the difference, except one had great frame rate and the other one had just barely playable frame rate. It was a 4K, I think, resolution that they were running at.
Yep.
How is this done so easily? And folks are saying it's never going to look good. I mean, there's a lot of doubt. I've heard some comments on our site and others where it's never going to look quite as good as natural AA, real AA, super sampling, or what have you. What do you think about that?
I think it's a great point. And with any new technology, it's going to take some time for people to digest what's really happening. But I think we'll try to make people understand the general idea. First of all, you got to start off with what's happening with deep learning and what does AI really mean inside of modern processors. And it's not that bad. It's not that hard to think about. AI is being used for everything from voice recognition to, picture identification and style transfer. So medical imaging, medical diagnosis. AI is the ability to take a lot of data and effectively create a neural network, which is effectively just a combination of weights that learn what are the common patterns of a particular data set and how can I classify using a lot of data and make sure that I get all of that data classification perfect. So neural networks use supercomputers and run just terabytes and terabytes of data to generate this really great combination of networks that now when you apply a new piece of data to it that the network's never seen before, it can generate a better outcome, right? It can predict maybe it's doing auto driving or maybe it's doing image generation. It can generate a better image than you otherwise would have been able to. So for us, we're using AI in something called neural graphics. And that's our term for meaning, okay, AI applied to graphics. And what we're doing is actually using the rastered image as effectively an input into this neural network that's been trained using our supercomputers. And these trained networks now look at the rastered image and say, that's a great image, but I know from looking at 64x super sampled data that really this line is actually something physical. It's a line, and I know that we don't need to really kind of use a mathematical AA algorithm. I'm just going to draw a perfect line. That's kind of what AA can do. It doesn't really need to do these sort of neighboring pixel super, AA modes. It can actually understand a little bit higher concept about what the frame is communicating. So it's really an amazingly effective technique in many, many industries. And now that's come to gaming. So the way I think about it is DLSS is applying AA to a rastered image, which is using normal techniques, traditional techniques, and then making that image look better. In the case of DLSS, we're actually making it look a lot better, right? You're replacing what was traditional AA modes and traditional super sampling modes. You're replacing it with an AA or an AI generated image. It's really an amazing technology. I think it's going to change a lot of the way people think about graphics going forward.
So I want to ask, how does this get delivered to the consumer, the gamer? And we know that you said, I think it was noted that, the developers, game developers will send in code, but walk us through sort of, womb to tomb, how this gets to the gamer.
Well, there's a couple different ways this will be taken advantage of. Of course, given the APIs that are available, a game developer may choose to just roll their own, right? Develop their own AI algorithms, develop their own image algorithms, but they could use AI for anything in their game. It's another tool in the toolbox, and it runs really well on Turing. So I suspect you'll see all kinds of crazy not crazy, but innovative new AI developed by not NVIDIA, but that runs on NVIDIA hardware. But the more common way that I think you'll see these networks is NVIDIA will use our Saturn V supercomputer, and we'll get a particular game that we are trying to accelerate with DLSS. And so in partnership with these game developers, they'll give us early builds, and we'll run trillions of patterns, and we'll generate an incredibly enormous amount of training data, and we'll train a network probably for that game. We'll learn what is the exact way that we should do a neural network for that image. And then that neural network will be delivered initially probably directly through game developers, but eventually that could be updated in real time. But think of it as that neural network is now integrated into the game and the game engine, and it just to a user, it just looks like I got an update of my game. Now it's got this new mode, which is called DLSS. I turn it on and I get better gaming. So I don't expect end users are going to be like picking the neural network that they want or picking options for a neural network. They'll probably be, experiencing this as a downloaded update to a game.
Gotcha. And actually a question came in on the chat. How will DLSS handle the different game settings by users, like disabling PP effects?
Disabling PP effects. Yeah, I'm not sure exactly what he's referring to. Yeah, but it's a good point that depending on the mode of the game, networks need to adjust. So my expectation is there'll actually be multiple different network weight sets that are tuned to different collections of settings in the raster. So think of raster as generating an image that gets fed into the network. And sometimes those networks are going to need to be trained differently depending on the actual current settings of the game. Now, it could be that we could make one network work really well for all reasonable settings, but it's kind of unknown at this point.
Yeah, post-processing. That's one of those acronyms we didn't pick up.
Yeah,
PP,
I view it as, yeah. Oh, I see. PP is his point. I view this as, the whole job of a game is to generate beautiful pixels. And what we've known for some time, because NVIDIA is the leader in AI, of course, and we do medical imaging, we do, stock market, and, we are the engine that's driving all of AI, not innovation, but really the guts of how AI works. We have huge internal teams working on AI. And what we've been able to do is take that, knowledge that AI works in a lot of really diverse industries, a lot of really diverse problems, and now we can apply that to our core gaming business. So it's just such an exciting innovation, and having the hardware on board makes it run really, really fast.
Beautiful. Yeah, no, sounds great. Marco, what do you got over there? I'm sure you've been capturing some cues.
So I do. I'm gonna riff off a question. I think Tom already answered it, but I'm gonna ask anyway because it came in on the chat. Someone had asked if indie game developers will be able to take advantage of something like DLSS, and since they can roll their own algorithms, I'm gonna assume the answer is yes. Is that doable?
Well, again, I think it's doable, but is it practical? If you're an indie developer, AI is not a small undertaking. It's
right.
There's a thing called data science, and there's the process of architecting a neural network and then working with CUDA to implement it. So I think that it's much more likely that indie developer would need to work with NVIDIA, and then through our developer relations and content tech teams, integrate AI into the game. And we are working with a lot of great titles. They're not all huge AAA titles. So it's really just, are you working with NVIDIA? It'll be a whole lot easier if you have a relationship with us.
And, gotcha. And correct me if I'm wrong, Tom, actually. Let me just segue on that, Tom, real quick. A game developer can send their code to NVIDIA to, crunch machine learning AI on your supercomputer for free. Is that correct?
Yeah, I mean it's not a pay to play thing. We have a deep relationship with most key game developers in the industry, and our relationship it's a win-win for everybody. We want game developers to get technology and get quality in their games quicker, because as games get better, it drives interest and excitement about new GPUs. So we have an immense effort to develop methods to help adoption of our technology. So our dev tech team and our dev rel team and even our engineering team is heavily focused on helping game developers not just use our new technology, but even using older technology, how can we help them make games better? You know, we're always changing our driver for different games. We're always giving them direct feedback. We have people on site, and none of that is NVIDIA being paid for that. That is something we do because it's in the interest of our ecosystem and in the interest of our gamers to drive excitement and to help that whole, you know, virtuous cycle accelerate.
Makes sense. Makes sense from a business standpoint for you guys to also, you know, as well, but certainly for game developers to be able to take advantage of the new hardware, the Tensor cores on board and all that good stuff. So yeah, getting access to those engines and optimizing performance on them. Marco, what else did you have lined up there? I'm sorry, I jumped in.
So, I mean, we have tons of new tech to cover. We still have to get to NVLink and lots of other features of Turing. But I think we've got lots of questions that have come in since the announcement about current games and how Turing is going to behave with current games that aren't specifically coded for some of the tech that's in there. Now, I know the GPUs have more cache and wider caches and higher core and higher CUDA core counts and different clocks. But what can gamers expect? Let's say a gamer has a 1080 now. Could they expect a 2080 to be a faster card? Is the experience with current games going to be better for users of your current technology who may want to upgrade to Turing?
Oh yeah, I think Marco, that's a great question. I think we could have done a little bit better on during the public announcement. But the fact is that Turing, just the traditional Turing, where you think about shaders and you think about memory bandwidth and all that kind of stuff, Turing is a beast, and Turing is going to significantly improve the gaming experience on old games, and it's going to just rocket when you adopt new technology, right? So we didn't do Turing just for deep learning and just for AI. Turing is our next step. In that normal, you know, progression of NVIDIA GPUs getting better every couple of years, Turing is our next big step. So, you know, we did share some data that showed a bunch of games, looking at things like Final Fantasy, PUBG, and you'll see the perf roughly somewhere between 35 to 45% better at roughly the same generation. So 2080 Ti to 2080 Ti. And of course, that's going to vary based on the game and based on the setting. So if you are CPU limited, like if you're running an older CPU and you're running at lower resolutions, then really the GPU can't do anything because you're already, you know, you're not giving the GPU enough work. And in those cases, well, you know, we don't actually, you know, we don't get more work to do, so it runs the same. But in most cases, if you're paying, you know, if you're buying a high-end GPU, you have a higher-end resolution monitor, higher refresh rates, you're turning on more of the eye candy. And in the places where you are, in fact, GPU limited, where you're seeing performance impacted by the GPU, Turing is going to crush it. And it's a combination of faster shaders, you know, faster clocks, wider memory bandwidths, and architecture improvements. So even running existing games, you're going to see a nice bump.
Yeah, I want to say
we actually have. Oh, sorry, Dave. Go ahead.
Yeah, no, I was just going to say the actual question was, and I don't know if we can pin you down enough on this, Tom, or not, but should we really expect a 2080 to be 50% faster than a 1080 in all of our current games, at least in a general sense? And I think what that reader or viewer is referring to is the chart that NVIDIA had handed out to the press that said, you know, here's a slew of games. Here's what it looks like without DLSS enabled, and here's what it looks like with DLSS enabled. The standard without DLSS was right around 40 to 60% faster than previous gen.
I think that's accurate, assuming that you're running at a mode or a game that is GPU limited. So if your GPU matters in the sense that you're running 4K, or maybe you're running at 25 by 14 with a higher refresh rate, or you're running with more eye candy, then you know you're going to see more frames. But if you're running at 250 frames per second and your CPU limit already, then it doesn't matter. So I like to get as accurate as we can, which means that 2080 is going to be much faster than 1080 for most cases. And it's specifically in cases where you care about the GPU, it's going to be a lot better. And 50% is actually not that far. That's a pretty good number to keep in your head. 50% faster on traditional games running cases like 4K where you care about the GPU performance.
Gotcha. Great. Cool. Marco, go for it.
So yeah, so just to sort of riff off questions that are coming in live. Now, I know we just made the comparison between, you know, 2080 and 1080. Are there going to be instances where a 2080 might outperform a 1080 Ti? I
think so. I expect you'll see, just like today, the 2080 Ti I'm sorry, the 1080 Ti is significantly faster than the 1080, and I'm not exactly sure if I would call that 50%, but it's it's close. So I would say I don't know the exact numbers, and I don't know if we've talked about it publicly, but I would expect some cases where 2080 is going to beat 1080 Ti, although I don't have the data in front of me, so I can't really say for sure.
Now, and over and above, the stuff that you've already talked about, about the more caches, wider caches, the additional memory bandwidth, are there? And I'm not sure how much you can talk about here because I wasn't at the deep briefing, so I might be asking NDA stuff. Are there also changes in the GPU to help with utilization? So not only is it the new CUDA cores and the higher CUDA core count, but are there efficiency improvements as well to make sure that GPU is working more efficiently to improve performance?
Yeah, Marco, that's a great question. I mean, obviously, we have an incredible engineering team. Jonah leads that team, and Emmett and all the other guys, they do incredible work, and they spend their life looking for ways to make this more efficient. Now, we talked a little bit about the way the caches are working are improved, the way, bigger caches, faster caches, but also we're doing better things in terms of the way instructions are moving through the pipeline. So better things in terms of how integers are being handled. And all of this detail will be coming out in more detail as the tech press NDAs expire. But right now, let me just assure you that yes, we are doing more things to make sure that core runs faster. It's a much improved native shader core, and that's what delivers a significant portion of that perf improvement for games. So think of it as, yep, we have totally improved the way instructions move through the machine. We've improved the way parallelism happens in the machine. And that's not even counting the advanced shader techniques and the advanced cores that with content, you'll see even more dramatic perf improvements. So it's a pretty exciting part, and you're going to see pretty significant improvements.
Nice.
So, and this isn't directly related to games, but I'm going to ask this question before I forget because it came in on the chat. So Adish is asking, is it possible to run different programs on different parts of the GPU? I.e., is it possible to run a Tensor Core program, a ray tracing program, and a CUDA Core program simultaneously on Turing?
I would not expect people to actually run separate programs at the same time. I think it may be possible, but I'm sure it would be super inefficient. But inside of one program, you will certainly take advantage of all three different types of cores. Actually, there's really 4 different things to think about. But there's you'll see real-time ray tracing core work happening at the same time that you see shader core happening, right? They'll be working in parallel. Sometimes you'll see integer instruction flow happening at the same time you see floating point instruction flow. And these are all workloads coming from the same app. And now, of course, you'll see Tensor Core activity happening, but you'll see Tensor Core activity is generally going to be happening when the other two are not happening. So you're kind of sharing more resources when you're running a deep AI program. So you're not generally going to be running like real-time ray tracing at the exact same moment. In terms of a workload, like for one frame, you can certainly see floating point shader core code happening at the same time you're doing RT core code, and those two things are occurring at the same time. And then you'll see the workload shift to that AI portion where it's taking the rendered or the rastered image and it's going to improve it, and that work will happen kind of as a separate phase.
Gotcha. Cool stuff.
Excellent.
Yeah.
What else do we have?
The real way I think about this is, we have added to, the Turing is just going to be faster for existing games. But what we've really done is we've made an investment in the future, right? We always do this. And you know what? Sometimes it's a massive investment. Like when we did sort of that compute shader stuff, when we did G80, it was just a massively disruptive. It was also very big when we did all the tessellation stuff. This is of that same order of magnitude. We're developing and investing in large area to make the future of gaming dramatically better. And it is, you can't ignore our current important business, which is, hey, we're running DX11, we're running DX12. Let's run that better. And we totally killed it on that. So we're going to run existing games better, but we're also at the same time making this investment that's going to be making games better. And right away, DLSS is just an obvious better way of doing these higher resolution images. And I think people are going to pretty much love it when they see it.
Yeah. Yeah. I will tell you, I saw it live and I was impressed, and I was peering at pixels. I'm looking at it going, okay, let me see if I can really tell the difference. And, it was a beautiful looking game, and it looked great, and it was running at, over 2x the frame rate in some cases. So I was just fine with it.
Yeah,
it's good stuff.
We're applying our data scientists to frame improvement for gaming, and that's just an entirely new muscle in the computer science community. We're doing hybrid neural graphics, and that just sounds cool, right? I think it's. I'm pretty excited about it.
Yeah, no, it does sound cool. No, it does sound cool, and and it makes perfect sense when you think about your technology and what NVIDIA has developed over the years for AI in the data center and machine learning and deep learning, even machine vision for some of your technologies and autonomous driving, autonomous vehicles. Taking advantage of that hardware in a game shouldn't really, if we think about it, be all that different, because you're talking about image recognition, and rendering and re-rendering and interpreting what the machine is seeing and learning. And so, yeah, it makes perfect sense. Why not?
Yeah, I would also add, and this is just me geeking out for a second, but AI is it's such a fertile area. It really is. It is known to be the place where just amazing amounts of innovation are happening. And we're doing it right now for improving an image, but now we're also deploying AI hardware into millions and millions of graphics cards that are going to be distributed all over the world. And so think of it as we're seeding a platform of innovation, and all these kind of garage computer scientist guys are going to get basically supercomputer level AI perf handed to them. And who knows what's going to happen? I think we showed a few examples where you could use this same technology for other things. Maybe it's for game AI, maybe it's for collision detection, maybe making it just horses not float above the ground. There's so many gaming applications for AI that it's going to be pretty cool.
Excellent.
So
Excellent.
Just quickly before the question rolls by in the chat, someone asked, can games use DLSS and ray tracing simultaneously at the same time?
You can certainly use it in the same application, and you will, as I explained, when you're literally doing that ray tracing portion, you're kind of doing ray tracing and you're doing shading, and those two units are kind of collaborating together. And that would pretty much say that you're going to render an image using a raster flow, and then you're going to pass that off to the AI processing. And so it's not really running at the same exact moment, but it is running in the same frame, and it's running in the same application.
Got it.
So I think the higher level question is, a gamer will be able to turn on both features in a game.
Absolutely.
It's not.
I would expect that, and I think in that initial game list that we sent out, you'll see some games are implementing both.
That was a great question.
So should we move to NVLink, because we're getting tons of questions on NVLink?
Yeah. I was going to say, let's move to NVLink. We've got a bunch. Yeah.
Okay.
So I'm gonna put Tom on the spot a little bit, because I think Jensen may have slipped at one point in his talk.
Oh my God! I don't believe it. I don't believe it.
When Jensen was talking about NVLink, he had mentioned briefly the Quadros that were announced before the GeForces, and at one point he said with NVLink, the two cards sort of act as one. So now NVLink, for people that don't know, these are new connectors that have replaced the traditional SLI connectors. They have much more bandwidth. I believe it was 100 gigs of bandwidth bidirectional on the higher end cards. So what can you tell us about NVLink, and does it enable new SLI modes? Maybe they're not called SLI anymore, but modes for multi-GPU setups.
Multi-GPU, yeah.
That is actually a very good question. Very good question. So I don't recall the exact moment when Jensen was talking about NVLink, but in general, he's absolutely right. NVLink is an extremely high bandwidth interconnect, and we said 100 gigabytes. It really is 100 gigabytes. It's 50 gigabytes at the sort of the lower end SKU. So think of it as even at 50 gigabytes, it's still a giant amount of bandwidth. So the question is, what is that good for? Why would you do NVLink? And the truth is that it allows two GPUs to cooperate in a much more intimate way versus what they did in the past. In the past, SLI was actually what's called a display bridge. And that means that the bridge transferred pixels, fully rendered pixels from one GPU directly to the output point on the second GPU. So think of it as one GPU renders one frame, another GPU renders another frame. And then at the very last moment, instead of re-showing the old frame from the second GPU, I'm going to allow the other GPU to kind of transfer its pixel directly to my DisplayPort output. So that's called a display bridge. And that's what NVLink did. I'm sorry, that's what the traditional SLI bridge did. And I showed just some rough bandwidths for that, but that bandwidth requirement is somewhere between 1 and 4 gigabytes of bandwidth on that old link for that display transfer. Now on NVLink, we're talking about 2 orders of magnitude more bandwidth than our original link, much more bandwidth than PCI Express. So with that kind of bandwidth, who knows what's going to happen? That bandwidth is now available to game developers, so they can certainly send transfers across that link if they choose. It's a memory link. It's not a display link. So that means that effectively you can sort of tickle the other guy's frame buffer, and you can say, "Hey, what's in your frame buffer?" And the guy can say, "I don't know what's in your frame buffer," and they can go back and forth. So
we got to record that soundbite.
What's in your frame buffer? Yeah. So at the end of the day, NVLink is really setting up an infrastructure for future methods of multi-GPU cooperation. Now, today we're using NVLink to make SLI better. So I showed a little bit of data that said at 50 gigabytes and 100 gigabytes of data, we can actually transfer a little better the modes that are already supported with SLI AFR. So that means, if you're doing 144 hertz 4K surround, that's such a big topology that it couldn't be transferred across our link in the old days. So that transfer would have to go across PCI Express, and it had all kinds of funky, competition. It's a lot of bandwidth moving through PCI Express. PCI Express is still being used for like CPU commands and, commands to the GPU. So that is really a bad strategy, and it led to a bad or less awesome experience for that display topology. On NVLink, all of that goes over the bridge, and we get much smoother performance for that configuration.
Cool. And just to get highly technical for a second, because we have another question that came in from a developer in the chat. He's asking if GeForce users. Let me just get the whole question in my head. So NVIDIA Collective Communications Library, the Nickel library for developing a top NVLink, will GeForce users get access to that for playing with communications and buffers?
I expect that the answer is yes to that. So NVLink is a software visible capability, and it's going to be exposed primarily through the DX APIs. I'm not sure exactly. Nickel is not. I'm not super familiar with that, but the DX APIs will expose NVLink.
I had a question, generally speaking, in terms of when you were talking about, hey, what's in your frame buffer? And the way I understand the way NVLink works in machine learning and supercomputers, high performance computing, you now have, let's say in the case of 2 8 gigabyte frame buffer cards, you now have a contiguous 16 gig frame buffer. Is that or is that too simplifying it too much?
I think that sets the wrong expectation, right? When people say that, they're trying to say I can now game with 16 byte textures, right, or 16 gigabyte textures, and it's really that style of memory scaling will require app work, right? It's not gonna just magically share that memory. Now, it's true that you could set it up to do that, right? You could set up the memory map so that effectively it looked like a giant frame buffer, but it would be a terrible performance thing because the game would really need to know that there's latency to access that second chunk of memory, and it's not at all the same. So think of it as it is true that this is a memory to memory kind of link, but I don't really think of it as magically just doubling the frame buffer. It's much more nuanced than that today, and it's going to take time for people to really understand, hey, NVLink is changing the way I should think about my multi-GPU setup, and effectively maybe I should start looking at new techniques, right? And that's why we did NVLink. NVLink is not really to make SLI a little bit better. It's to lay a foundation for future of multi-GPU.
Got it. One of the readers asked, is micro stuttering a thing of the past? With NVLink.
NVLink certainly can improve micro-stuttering, but I don't think micro-stuttering is going to go away with NVLink because honestly, micro-stuttering is more about the current technique for doing multi-GPU scaling which is called AFR, right? And AFR effectively sends one frame to one GPU and another frame to another GPU. Now, a lot of stuff happens, right? These GPUs have frame buffers that are all separate, and they have to make a lot of commands to memory, and they have to, do interrupts, and they're basically independent. So if one GPU takes a little bit longer than the other GPU, or if there's a little bit of wiggle between those two, then by the time you combine those frames back together and send them to a user, there's a little bit of shift in terms of the presentation cadence. And that shift is what we perceive as microstutter. So I feel like a lot of that is fundamental to the way that AFR works. It's an algorithm that's distributing work and then bringing it back together. And that's the fundamental challenge. Now, we've done things like metering in hardware, and we still do that on Turing, by the way, which improves that. It kind of smooths out the frame delivery. So it's much more minimized on NVIDIA GPUs, but I don't think it's going to go away entirely. More importantly, there are other things that can be done, other multi-GPU technologies that I think are actually much more compelling in the future. But we're not ready to talk about that today. Think of NVLink as it's a platform. And just like, it's a long-term investment. It's going to be with us for a long time. And what it does is it makes our two GPUs much closer to each other, much closer so that they can share information, they can share data, and they can communicate to each other without worrying about what's going on PCI Express.
Cool. Very cool.
So we're I know we're running short on time, and I have a bunch of nuts and bolts questions I want to rapid fire at you. So just really quick, any insight on why 2070 doesn't have NVLink?
It's really about the market and how they use SLI at that level. So typically the 1070 has less attachment than the 1080 or the 1080 Ti. So as we look at cost and we're trying to develop the perfect product for that price point, it's really a feature benefit. And for 1070 class, it's not heavily attached. And since it's not heavily attached, it's an opportunity for optimization.
Gotcha. And I know now, just getting into some of the nuts and bolts here. Jensen had mentioned that the current crop of cards, even though they're not out yet, they're still new, that they're overclocking like crazy. So you guys have disclosed boost clocks on your site. We have a range of cards with some clocks, and then the Founders Editions with somewhat higher clocks. But if you're a nuts and bolts guy and you want to get a 2080 Ti and start overclocking, do you have any insight on what we can expect out of these guys?
I think you're going to be surprised that it's really good. The 2080 Founders Edition, as an example, has been built for overclocking. It's got an amazing power supply, a ton of headroom on the power side and also on the cooling side. And that's intended for you to just crank things up and really go for the max. The chip is also faster than I've ever seen. So when you just look at raw clocks of Turing versus raw clocks of Pascal, everybody was kind of amazed when we showed 2 gigahertz at the launch of Pascal. That was like, 2 gigahertz, what are you guys doing, liquid cooling back there? And I was like, no, this is just Pascal's fast. This is air cooled. As a matter of fact, that demo was shown with a Pascal Founders Edition back in the day. I don't know if everybody knew that. It wasn't like a funky demo. But on Turing, we also showed, I did during our editor's day, I showed 2.13 gigahertz, and that was just a random card. And I was showing some new tech that we're also launching called the NVIDIA Scanner, which is going to make overclocking even easier for end users. And you'll hear all about that stuff as the NDAs start to expire. But I'm excited about the overclocking. I'm excited about the Founders Edition. We've got a whole new boost. We haven't even talked about the different ways for people to control their GPUs. And I think you're going to see some pretty cool excitement. We're always looking for ways to help enthusiasts get the most out of their GPUs. And GPU Boost 4 is part of that. The scanner is part of that. And just the raw clock rate is part of that. And also building these boards that are just hugely designed for overclocking. I think people are going to love it. I hope.
Cool. I have to jump back to NVLink for a second because it just dawned on me. This is a great question because it is 2 different kind of interconnect technology. Will the 2000 series RTX cards with NVLink support previous gen SLI games? Do you get multi GPU from previous games with NVLink?
Excellent question, Marco. So SLI as a brand and like SLI motherboards and SLI games all work on Turing. So what Turing has done is it basically says we're changing that link on the top. So you'd need a new NVLink connector to connect two Turing cards. But all your SLI games, all your SLI profiles, all your SLI motherboards, all of that remains unchanged.
Gotcha. So, and now some more nuts and bolts stuff, because we're definitely getting short on time here. There's been lots of questions on pricing. NVIDIA announced a group of MSRP starting at $499, and then partners came in and showed off a bunch of custom cards, and obviously nothing was sort of as low as MSRP. Could you give some insight on why there's such a wide range of pricing there?
Yeah, I mean, the way I've always looked at pricing, and I think it's true, is that the market is going to demand all kinds of different cards. And that's the power of the model that we use to get to market, right? We make a chip, we make a reference design as well, and we give that to all of our partners. And then they go crazy, right? They're off designing all kinds of exciting different parts. Some are, super high end with 3 coolers and giant, heat pipes. Others are a little bit more cost sensitive. So the partners are basically going to hit the entire price point range between our entry level price, which would be $499, up to whatever they feel is the appropriate price for the value that they're delivering. So I think everybody wants this, right? Everybody benefits from having tons of variation in the market and having a lot of competition. So in my mind, really the question is saying, am I going to ever see those entry prices? And the truth is, yes, you will see those entry prices. And it's really just a question of how are the partners approaching the market. Typically, when we launch, there is more demand than supply. And that tends to increase the at-launch supply price. But we are working very hard to drive that down so that there is supply at the entry point. We're building a ton of parts, and it's the natural behavior of the market. So I think there's really nothing going on here. It is like most things. When they're first introduced, supply is low, demand is high, and prices can sometimes elevate. But NVIDIA's approach to kind of solving that and making sure gamers get prices that are fair to gamers, we drive volume. And when volume comes into the market, that's when prices normalize.
Yeah. I had a question actually on the reference design, your Founders Edition or what have you, the traditional 2080 Ti. You went from a single fan, squirrel cage fan to dual fans now, totally redesigned cooler. Looks significantly, it looks advanced. It's certainly a little bit more cutting edge. Tell us a little bit about the impetus behind that and what your goal was with that, because they certainly seem to run cool and quiet, but is it because the GPU needs a little bit more thermal thermal support there, or is it just you guys wanted to improve on that design and give more headroom or what have you?
Well, there's a lot to that question. First of all, I'm super excited about the new thermal design. Obviously, our engineering team has been working on this for over a year, and some of the tech in there is truly incredible, like that giant vapor chamber that keeps the chip really cool. And the fans are all designed from scratch. I mean, this is like lovingly, handcrafted, polished love. And the truth is that we want our Founders Edition to be somewhat near the top end of how good can you build a card, because what we do for Founders Edition tends to sort of set the bar for how our other partners respond. So we took feedback last time that, blowers are great, but a lot of the market prefers dual axials because they are better in general at cooling. They can either cool more power or they can lower the temperature or lower the acoustics. So it is true that you just get more airflow, and it can, at the same power, drive lower temperatures and lower acoustics, or it can support higher power at the same acoustics and temperature. So we did it for both sides. We wanted to enable both, people that really wanted to overclock and really wanted to push it up. We want that to still give you a pretty good acoustic and temperature experience. But at the same time, we would like, somebody that's running stock to get a completely silent, beautifully, under control thermal acoustic experience. So it's partly in response to learning, right? We see that most of the enthusiasts that we see our partners engaging with, and we get a lot of feedback from press as well. They're like, hey, have you ever thought about a dual axial? I would prefer a dual axial. We want Founders Edition to be one of the best cards. And to be one of the best cards, we have to be willing to adopt new technology and respond to what we feel from the market.
There you go. Any potential in the future for water cooled or liquid cooled? You probably can't answer that.
I would say, I can answer anything. Why not? I would say it's unlikely that we're going to ship directly a water cooled block simply because it's a little bit harder to integrate. But if we can figure out a way to do advanced cooling, I'm not married to air as the medium for cooling. It just happens to be the best way to do it today compared to the complexity of doing a water cool integrated thing. It just gets big and unwieldy, and I don't think it's very elegant. But if it turns out that there's other new technologies that we can, adapt into our cooling, we will absolutely do that. I don't think anybody at NVIDIA is worried about water cooling or worried about anything, any kind of multi-phase, who knows, right? So air is the best way to do it today that we're aware of, but yeah, we're ready to do something different.
Sure. Marco, what else you got?
I think since we're nearing the end, let's go super high level and give Tom a chance to sort of just get everything off his chest. What do you think? What do you think is going to be like? So one of your customers, they're a current Pascal owner. They're going to buy a 2080 Ti. What do you think he's going to be most impressed with on day one when he puts that card in his system?
Well, obviously, the most impressive thing to me is going to be the combination of DLSS and ray tracing in the new games. When you see the high frame rate, the beautiful imagery, and also the effects that come from ray tracing, it really is a totally different way to play the game. And when you see how we played the game with Battlefield 5, it's just a great, it kind of warms the heart and says, hey, graphics is moving along, right? Things are getting better. Now, on the other hand, I'm also going to turn around that next, after I play Battlefield 5 for 4 days and I don't come out of my room, then I'm going to turn around and try all those existing games that I've got, right? And that's the best part about Turing. It's going to satisfy gamers that are pushing the limits today. They've got high-res monitors. They're like, I want to get that next level. I want things to be smoother. I want to turn on all that eye candy and see what these developers have done for me. And that's what Turing is going to do. So I'm kind of of two minds there, Marco. On the one hand, I'm a geek, so I gravitate towards, there's going to be some stuff that has never been seen before, and that is going to be amazing. But on the other hand, it's going to crush all of my old games. So stuff that wasn't awesome before, that's going to look much better.
Nice.
Cool. I am excited myself. I can't wait to play with it.
Cool.
Anything else? What else we got? Did we miss anything in the chat, or are we
there's been lots of riffing off questions that I think were kind of answered previously, or if someone comes back and watches, I think that they can infer their answers. We asked about overclocking, we asked about the different cards, we asked about pricing, NVLink, we asked about the new tech, the cores.
DLSS,
yeah. I'm sure we missed something, but I think we covered a pretty good swath of information here.
Tom,
awesome,
I got one
guys.
last question. I have one last question. What would be, and you've seen a lot of game developers and working with your new technology, what game are you most excited about personally?
Boy, which child do I love the best? I'm going to take a pass. I'm an old school. The game I'm playing, I'll tell you what game I'm playing right now. I play, and this is just me because I'm a geek. I play Factorio right now. Have you guys ever tried Factorio?
I have not.
I haven't.
Oh my God, that's. But it's like sucking hours of my life. It's a world builder, factory simulator. It's like for geeks, and it's like actually one of the highest rated games on Steam. So a little shout out for Factorio, but all the other new games, all the new effects. When you look at Battlefield 5, that's going to be a crowd pleaser. But I think they're all going to be pretty spectacular.
Yeah, folks are shouting Cyberpunk 2077 in the chat.
No doubt.
Yeah.
Oh, Metro as well. When you looked at Metro 2033, the new one, that's going to be pretty awesome.
Yeah, that was impressive seeing the demo there at the event. Yeah. Good stuff. Hey, Tom, thanks for joining us. This was fabulous. Absolutely fabulous.
Yes, sir. Thank you very much. I'm always happy to talk to you guys. I get it's a substantive conversation, right? We're not talking bullet points and there's nothing prepped. I love it.
Yeah, it's great. Great to spend some time with you here and learn a little bit about more what to expect. And I think we answered some questions too. I think folks had a lot of gray area that they were sort of trying to cast an opinion on, and I think you really helped here in a lot of those questions. So thank you again for your time. Good stuff.
Hey, hopefully people are getting a better understanding. It's going to take a lot of this, where we're helping people understand what have we done and what's new and what's not new, right? What's not new is amazing, perf, and there's a lot of new stuff in there.
Cool. Good stuff. Hey, Marco, you got any parting words before we say goodbye to Tom, before we let him go?
I don't. Just another big thank you. And for my Amiga guys out there, I'm wearing my Amiga t-shirt. Tom actually had a hand in developing PowerPC years ago in a previous life. So all you guys that are still playing with your Amigas, you kind of owe him a thank you as well. Good stuff there. But no,
PowerPC 620, baby.
There it is, brother, man. So yeah, no, I'm just looking forward to as a geek outside of my job, I'm excited that we have a new wave of GPUs coming. We had such an exciting year and a half for CPUs, and now it's starting on the GPU front as well. And just I've been saying it like every podcast. It's just a really good time to be a PC enthusiast. There's so much new tech and so much more power coming to the PC and to gamers in general. What we see on our PCs now and what we see a year from now, I think is going to be night and day, and I'm really happy about it.
Yeah, good stuff. Hey, Tom, thank you so much again. Folks, stop by HotHardware.com where you can find us on the web. Hit thumbs up and subscribe for Tom here. Absolutely, you got to do that. And stay tuned for our coverage of NVIDIA's GeForce RTX technology based on Turing microarchitecture. Good stuff. Tom Petersen from NVIDIA. Thanks, buddy. Good talking with you.
Thanks, guys. See ya.
Take care. Thanks for stopping by. And the slam close. Hey, Tom, that was excellent, Tom.